Finally got her degreased. I have not been so greased out in many a long year, but I got her done. So a couple of things. First of all, my obsessive personality got the better of me, and I yanked out that needle bearing. I couldn't sleep at night, so I yanked out the little needle bearing. So I was going to leave it alone, but decided not to. Second thing is, there's another reason why this was such an oily mess. First one was the gears that are in the gearbox here are lubricated with packing grease. And like I said in the teardown video, gets hot and starts leaching out oil. The other reason is right here. This is the oil fill cap. And it says oil every 3 hours. That goes right here. So somebody was following that religiously. Problem is that this chamber, which guides the yoke up and down, this yoke that moves the cutter up and down, and the gearbox are separated by this bearing. Well, this bearing is not sealed, so if I put my flashlight on it, you can see light going right through it onto my hand. So I'm going to replace this with a sealed bearing. So that will help keep the liquid oil that it lubricates the yoke out of the gearbox and hopefully prevent such an oily mess from reoccurring. So from that, I'm going to go order that, and when I get her, she'll go back together. So what I'm going to do now is I'm going to clean up and detail the castings. I'm going to take a wire brush to all the fasteners, the cutters, and just generally clean this thing up, get her ready to go back together. I'm also going to tap these 2 holes to hold the nameplate on with number 4 screws. So nothing to it, just a 440 tap. And just gingerly and gently tap these 2 holes. And we'll reattach the nameplate with number 4 screws when the time comes. Just go easy. This is an old die casting, and this is a hardened steel tap. So you're more likely to strip the hole than you are to break the tap. So go easy, lots of lubrication. WD is the best thing for aluminum. And just go easy. Little number 4 button head. Okay, there she is, replete with 2 brand new button head screws. Nice and short so they do not protrude into the motor housing. All I gotta do is hold on a little aluminum nameplate. Okay, ready to start the detailing. The way I do detailing is a very manual process. Start with the screw holes, the threaded holes. I just take a screw or a tap and just chase all of the threads for all the threaded holes. Make sure they're cleared out. Then I take a Dremel, which is the other main weapon, and I just start cleaning out all the interior passages and holes and everywhere where I can see there's either burrs or dirt that I didn't clean up. And it's just a tedious manual process. Okay, word of warning, when you're using a rotary wire brush, which is the weapon of choice for detailing for me. Couple things. First, a variable speed Dremel helps, because these things really shouldn't be run at 30,000 RPM. They'll throw bristles all over the place. Second thing is make sure you're looking at the back of the brush or the front of the brush when you're working. Don't be looking at the side of the brush, because that's how the bristles are going to come out, and they'll end up right in your face. And wear these safety glasses, because these little bristles get everywhere. A little bit of dry lube. This is interesting. So here's the little shoe. Let me zoom way up on it. You can see it on the camera. You can see a seam, two different kinds of metal, and a seam here and a seam here. So what that tells me is that this is one piece and this is another piece. This is a forging, and this is a separate piece, and they spun weld it on here. So they held that still, spun the heck out of this, so she welded herself together, and then machined out that pocket. They use that kind of technology to make hydraulic cylinders, but that's how they got this funny looking piece. It's actually two pieces. Next step in the detailing is deburring the castings. So I'm going to go over every casting, like over the edges, and the weapons of choice are 100 grit sandpaper and a Dremel with a little sanding drum on it. And if need be, they'll break out a burr, but generally this aluminum works fine with sandpaper. I'm just going to start going over the sharp edges and knocking it off and make everything nice and smooth and easy to the touch. All of our castings are now nice and smooth. No sharp edges. One comment. So I rebuild these tools to use them. I kind of like them all beat up and rough looking, as long as they're not damaged. Now you can polish this and bring it to a high shine and make it look really nice, but I'm not rebuilding these things to stick them in a museum. I'm going to use them. So even if you go over it with like a 220 grit, you can get a really nice warm, not shiny, but a nice warm glow off of this old aluminum. Looks nice, but again, these things are going to work. They're not going into a museum. So last step, I take this and I'm just going to spray everything down just to rinse off any residual grease or oil or aluminum chips or anything. Then I'm going to blow it all down, and I'm going to let it sit for a few hours, and then we'll start reassembling. So how does this thing actually work? So we have the switch, which is connected to the cord, which brings in current from the wall. The switch switches power to this lead and neutral or ground to this lead. So the power comes in, circulates through this upper field winding, and then out into this brush, which is, just imagine the brush is there, into the commutator, and then through the coils in the rotor. And then out the other side, the commutator on the other side, through this brush to the coil on the bottom side of the field, round and around and around, and then out to neutral. That causes the motor to turn. Motor turns this gear right here, this gear right here, which has 13 teeth on it, turns the big gear on the intermediate gear, which then turns the little gear on the intermediate gear, which then turns the big gear on the output shaft. So the overall gear ratio here is about 8:1. So for this to turn once, the motor has to turn 8 times. That slows it down by a factor of 8, but it also multiplies the torque by a factor of 8. So it is slow, but it makes a heck of a lot of torque. Then I just have this propped up on this on these wooden blocks and a nut down here. When this output shaft gear is rotating, it rotates inside this bearing, and the eccentric on the output shaft moves this brass block. So now taking a look at it this way. So this eccentric right here, I think you can see that that's eccentric. It's big on this end and nothing on this end. When it turns, you can see it moving eccentrically in the inside of that bronze block. That rides inside of here, and when the eccentric turns, it pushes the output shaft up and down. So here it is assembled. Here's the output gear. Here's the output shaft. There's the little bronze block, and there's the eccentric that the output gear turns. And this obviously is the shoe right here that holds the bits that actually cut the sheet metal. So the upper bit is attached to this shaft, and it goes up and down with this shaft. This mechanism is called a Scotch yoke. So as this turns, you can see the eccentric going around, and you can see the bronze block going and the output shaft going up and down, but you can also see the bronze block going left to right. So this is one of many mechanisms like a crankshaft that turn rotational motion into linear motion. So the block's moving this way and this way, but since this yoke's cutout is got relief on the sides of it, the block shifts back and forth and causes no motion, but it doesn't have relief this way. So when the block shifts up and down, it does cause motion. And that's it. That's how she works. So next video, we'll start putting her back together. I will see you thence.